Perfect. So my apologies for the misdirection in the information that was sent out in the letter. This is now my third meeting through Zoom, and the first two meetings worked with no issues. Something had changed on our website, and there was a small hiccup with the directions that I had provided in the letter. As you all know, they didn't work out with what I had said. So those of you that do miss the meeting because of misdirection or having to work or whatever the case may be, like I said, it is recorded and it will be on our website along with the presentation, hopefully by the end of the week. So at this time, what I'd like to do is turn this over to Paul Marsh. As I said, he is our appointed engineer for the report. He was appointed in 2019, and he's been working on a number of background things, including the baseline report for the municipal drain, along with the hydrology and hydraulic study for the municipal drain. So, Paul.
Thanks, Alana. And if you could share the screen for the first slide.
Here we go. Where did it go?
It's down there. Oh.
Thanks, Alana. This meeting's being held in recognition of the requirements of the Drainage Act to hold a public meeting or a site meeting at the beginning of the drain assignment. Typically, when we do one of these drains that has been around for a long time, rather than a roadside site meeting, my preference is to be able to study the drain a little bit first so that I know more about it, and then hold a public meeting such as this. I prefer public meetings that are in person than ones that are over Zoom. Zoom is okay, but it just limits our ability to talk to the local residents and to gain a better understanding of some of the issues. So the entire point of this public meeting is for me to tell you what I understand the drain is doing or not doing, and for you to tell me what you think it needs to be done or how it's working well or not working. So it's meant to be a dialogue. Because of Zoom, there are some challenges for us realizing that. And so if at the end of this, there are specific things you'd like to tell us, we'd very much like to hear them. And I would ask that you direct them to Alana so that she can coordinate them for myself and Dave or anyone else to be able to respond to. Next slide, Alana. So this picture was taken south of Matthews Road, looking at the culvert that is on the drain in this location. I believe there used to be a road that passed from north to south in this area. The picture was taken December 11th, 2020, 11:25 a.m.
You going like that?
Taken by a staff person from the town of Fort Erie. And you can see
my back.
there are some challenges with the way the drain's functioning at that time. Go ahead, Alana. This is our agenda for the day, which is, I've already talked about the role of the Public Information Center in the Drainage Act. I'm going to talk about some of the drain history that we've been able to put together, talk about the baseline report, some watershed modeling, discuss some aspects of the drain improvements that we've identified or are considering, and then conclude with what the next steps are. Go ahead, Alana. This is where we are in the Drainage Act, which is on the left-hand side, and we're at the Public Information Center number 1, identified there as PIC number 1. And it's where the engineer has done some preliminary drain investigations, and we're going to have this discussion today. After this, I go away and prepare a draft report along with plans, drawings, and specifications. We have a second public information meeting where I present what we're proposing to do, what it will cost, and how much everybody has to pay. After that, the engineer files the report with the city councils, both of them. and they go through a process of adopting the report in draft form, and then there's an appeals period. My goal is to, oh, we lost the presentation there. Alana, can you bring the presentation back up?
Oh, I think we lost Alana.
Okay, so what I'm going to try is I'm going to try to share my screen. And can I hear, that was Harry, right?
That's correct. And your screen is up now.
Beautiful, thank you. I'm going to go to where I was. And so the little hockey net at the bottom of this chart is showing what my goal is, which is to file the report with the city clerk. So I'm aiming to have the second public information center sometime this fall, if everything goes well. And then the report should get filed with both the city and the town before the year end. You know, we've had some challenges with COVID getting this far, and so it's hard to predict the future these days, but it's our intention to complete the report in this calendar year. A little bit about the drain history. This was composed by going through old records provided by the city of Port Colborne. You know, the earliest record we could find was a specification contract for construction of the outlet in 1892. There were some petitions for different things, and I have some charts showing when all of these things happened. You can see in 1926, there was a drainage court. The 1983 Point Abino Marsh drain prepared by C.J. Clark in 1983 is the last report of record. And in 1998, an Ontario Drainage Tribunal rescinded their original order requiring the installation of a low lift pumping station. There was an entire process, which I'll detail a bit more, in 96 and 95 to identify pumping stations. And that there was a drainage tribunal over that, and the cost of it was set aside and nothing was ever built. These are some of the plans that these reviewed, and I really just like showing these for how nice the old engineering drawings looked. We can't produce anything like this today when we use computers, and so it's just nice to see the historical drawings. These are some drawings from 1925, but to my knowledge, this is not what was built. The channel doesn't follow this path. This is the path that was recorded in 1927, and it identified the original drain as outletting along this short section here labeled 60+72. It used to go this way and outlet to the lake through this area. And in this report in 1927, they reversed this short piece and they went
Can you
all
try
the way
this again
along,
for me?
went
Logging
all the
in.
way along this back part here and then gained a new outlet down at the bottom. There's plans detailing the grades for sections 1, 2, and 3, which are 0.02% in 1927. So in 1927, this was already a very low sloped drain. And sections 4, 5, and 6 are detailed with a plan, and they're 0.04% over to this Holloway Bay Road South connection. That's still quite low as a drain grade. This is what was done in the 1958 works, which was nothing south of this position just east of Matthews Road. and then a deepening of the drain and an improvement of grade and extension of it all the way over into lot 3. And all of these numbers in here are done in feet and inches. That's what was done at the time. And it's also interesting to note that there was some rock removal in order to lower the grade sufficiently on this Holloway Bay Road south portion. This is the CJ Clark report prepared in '83, and it really consisted of 2 parts. One is on the outlet, which I'll talk about briefly in a minute. And this inclusion of branch number 1, which was a north-south connection along Holloway Bay Road, following the original path of the Haggerty drain. And the design showed extending north of Michener Road, but the actual construction only went as far as Michener Road. There's a record showing that this part, the north part, was set aside and not completed. This is in CJ Clark report in '83. There are a layout for a pump station, and I got a little bit more on that later in the report. This is the 1995 report that was prepared by Planco engineers, and it was to locate a pump station for the west side, either on Pleasant Beach Road or Holloway Bay Road, in order to pump runoff off the drain out to the lake. The estimated cost of 95, 155, which if we adjusted it to today's dollars, roughly $250,000, but it excluded property acquisition, legal, geotechnical, environmental requirements. There was a tribunal over this, and it was basically, the original tribunal was that this report had to be prepared. Report was prepared, nothing was ever constructed. This report, Planco Engineers 1996, same kind of thing, 190,000, which adjusted would be 300,000 with the following exclusions. The hearing in 1998 set aside the original order, rescinded the preparation of or the duty of Port Colborne to construct a pump station. And this was brought about because people opposed the cost of constructing the pump station at that time. So there were plans to build a pump station, but the residents in the watershed at that time opposed it. Just a brief little point on the eastern boundary of the drain. We made some potential revisions of the boundary based on the 1983 Clark report, and that's showing in here in some of the historical layout of the town, where the original town line road was, and where the split between Fort Erie part and Port Colborne part. We used the terminology going forward in Point Abinal Drain. The historical terminology was the Point Abinal Marsh Drain. The East Branch, which was shown in 1927, has no other record that we were able to find about it. And so as far as we can tell, it still exists as a drain. It was never abandoned, and so we believe it's still part of the drain. And so the town of Fort Erie is conducting a study of the Point Abinal Road pump station, which is located down here in the green little lines. And that study has provided us with a revised boundary, which we're showing on the plans here, which is the lands that would drain towards the Point Abinal Road pump station, and the lands otherwise would drain to the west into the Point Abinal drain. So I just want to make a distinction that anybody that's affected by the pump station won't be affected by the drain, and vice versa. So I'm just going to do an overline of the baseline report. The intention of the baseline report is to state what we know about the drain and what its current issues, conditions, problems, or successes are. And this is the Point Abinal drain as its geography or geology or geomorphology. And there's really an entire low part of the drain, which historically we saw is 0.02% and 0.04% over to this point here. And so it's quite slow draining to the east and draining to the south and out again. Along this western boundary are the sand dunes that is the interface with Lake Erie. This is overlain on the Onondaga series of limestone. And this upper portion is really the upper portion of the watershed. And it's really the part that actually has contour lines, suggesting that there's fall from the part of the drain that's up here to this point. The blue line marks 176 as a contour or elevation, which means that the drain south of that is below 176 as an elevation. So I'd like to describe this in an analogy, and that is that this drain is kind of like a bathtub, where the lower part of the drain is the bathtub, and one wall of the bathtub, instead of being made out of steel, is made out of sand. And the sand is porous, and so it lets water both in and out. And what happens is when the lake is high, we get water that moves into the tub part at a very slow rate, but it moves into the tub. And similarly, when the lake is low, water will move out of the tub into the lake through those sand dunes. What we're really interested in is that when it rains, it acts like a bucket pouring water into the tub. And the level of the tub is controlled by how fast it can get out of the drain of the tub. Similarly, this drain functions by how fast it can get out the outlet, which is compromised by these blue arrows and how slow the water will move from this point to the outlet. And so the level in this thing is controlled both by the water that's moving in and out of the dunes, but as well by the water that's coming off the highlands into the low area. As part of our study work, we've conducted a survey of the upper part of the drain. And if you recall the original picture that I showed, we have survey points from that, thanks to a town of Fort Erie staff person, Troy, who waded out and picked up the inverts for that culvert.
Wow.
But to do a physical survey of that entire area at that time was not going to work out. Above that, we have survey points, and the survey points allow us to prepare base plans that look like this, where this line is the actual survey points that we found. This dashed dot line is the original design that was prepared in 1983. And it shows a 0.33% grade. And this is on the branch one profile as an example. And it's showing the left and right bank and the culverts that cross. And the blue line is standing water in the drain. And you can see here that there's quite a little drop here north of the Holloway Bay Road South culvert. And then there's a bit of a high point that's close to the original drain grade, but it creates standing water in here because this is acting as a hump, preventing it from getting over and out. This upper portion here is fairly close to the original design grade, but it's actually a little bit better, a little bit steeper than the actual design indicates. So overall, this watershed has about 2.6 meters per 1,000, which is mostly related to the upper part of the watershed. The average slope is 0.14%. I've already talked about how it's split, and we have two control gate sill elevations, 172.796 and 173.806, compared to the lake bottom at 172.82. And the average given depth of the lake is 174.15. So on average, these sills are still below water. This is just the drain overall, and it's an Excel chart, so you don't quite get the same engineering presentation as the profiles give you, which are to scale both vertically and horizontally. This is just everything vertically. This gray section is the branch one, and you can see it's quite steep relative to the rest of the drain, which is really quite low. So what we would prefer to see, all things being equal, we'd like to see 1 meter of fall per 1,000 meters, which is 0.1%. And if we go over here to where Holloway Bay Road is, 3,500 meters, we would want to see about 3 meters of fall for a good drain. And there's just not a way to get that with the Point Abino drain. It's just the geology that's there. We're down in here at around 0.02 that entire way across. The environment in which this drain exists, this is from the National Ocean Administration, and it's showing the impact of a sesh condition where wind-driven waves is surge. This is a high-low pressure from one end of Lake Erie to the other, and it's showing in and around here a 3.5-foot increase, which is relatively small. We've seen this get quite a bit bigger than this, but it's a phenomena that happens across the west end of Lake Erie and the east end of Lake Erie. It's the reason why we have flap gates on the outlet. This is showing what would happen if we didn't have those flap gates. And the dark blue are elevations that are right around the 174.15. It's really from 173.7 to 174.5. But on an average Lake Erie day, these dark blue points would have water influenced by the incursion of water through the sand dunes anyways. As you go to the lighter blue areas, the ground's higher. So until we get to green, we're really not out of where the low areas are. And so you can see there's fairly extensive low areas in here. The pink here is 176. And so there was a storm, let's see, October 31st, 2021, I think. And we did a measurement east of here and back in from the lake, and it drove that drain backwards to a 175.45 level. I've got another little part showing that later. But you can see that this entire area would be significantly flooded by that high of a lake level. This is where that photo was taken from the very beginning, is right up here. Oh, and here's our flood levels, and this is the outlet as it exists today. It's got the outlet down here, and then these are all our survey points being shown above. Property lines for both the Point Abino Road and the Abino Hills Road. The culvert's a twin box culvert built at different times, very similar sizes. One's slightly deeper than the other. This is the average Great Lakes elevation, 174.16. These are the two surveyed flood elevations that we've recorded in the past in a different part of Fort Erie, 2019 and 2020. 176.45 is roughly what we're going here. So that's the observed surge sesh that we have here, 6.8 feet rise or 2.072 meters from average. The town of Fort Erie had this outlet inspected in 2021. The inspection used underwater cameras and underwater divers. It's the only way to conduct an inspection of a culvert that's underwater most of the time. These are the results of that inspection. This is the company that performed it. This is just a summary of the report. Retaining walls on the east side undermined and voids up to 1.2 meters in depth. The north cell, medium to severe scour, cracking, voids in the side walls, multiple holes through the center wall, cracking around the CSP. South cell, medium to severe scouring, one significant spall with exposed rebar. North cell is in poor condition, south cell is in fair to poor condition. The recommendation was to replace it within 1 to 5 years and to begin monitoring the roadway for settlement to prevent the risk of sinkholes appearing. So the baseline kind of identified that the issues that we have are challenges with the existing grade lines being slow, static water in the lower half of the drain, some culverts that may require repair and or replacement, an outlet that should be replaced within 1 to 5 years. The flap gates reinstalled in 2020 have been working after their repair. This one here is, I don't believe there's any specific petition-based request, although I am aware of one that's on off Point Abino Road. I want to say Willow Road, but that doesn't sound right. So there has been a petition for some works there, but the main one is the possibility of a pump station based on a petition, which I'll talk about briefly. There may be opportunities to change the way the drain works to make some parts of it more natural, which would see an increase in flood capacity, but a decrease in low flow so that there's less standing water. But there's some challenges around that. I was in a meeting previously on the Point Abino Road public meeting where they talked about having some berm options along that north-south last part on the east side. But that would have to be done as part of this drain report if it's to proceed. As part of that naturalization of the drain, there's the opportunity to do wetlands. Wetlands allow us to store water that otherwise stops it from flooding. So we have more water than we have places to put it. A wetland lets us designate a specific spot that we're going to flood every time there's a significant rainfall. Other drains I've done sediment basins on, but this particular one, there's not the same level of farming upstream in the areas. And so we haven't seen a great need for sediment basins. And then this is really what a natural channel designs is. There's a low flow channel, which reduces the amount of standing water, but then there's significant flood zones that are identified. And it's not the traditional trapezoidal shape that we would see with a traditional drain design. This is the outlet, and you can see here that there's a different color, and so it definitely is flowing out. And there's some issues with this, given that there's a pumping station report from '97. The control structure has limited capacity. It's there really to control surge and control that. There are some opportunities to make that work a little bit better. We could have flow level monitors and have active control on the gates. I'm not sure, that may or may not work better. There's no trash rack on the entrance, which oftentimes we would see a trash rack to prevent material from coming in and getting plugged or stuck. And then the steel culverts, they have to have a certain velocity of water in order to push them open. And so there's some resistance based on their weight to how much water can get out. The outlets look like this. This is a comparison on the topic of pumping. This is the Beaver Dam Drain, which is to the west of the Point Abino Drain in the city of Port Colborne. This pump station was implemented in 2000, so it's almost 25 years old, roughly 22 years old. And it's a tractor. Tractor provides the power, and it's an impeller, vertical impeller shaft in this part of the housing down here. And the tractor drives out, hooks up, and runs until such time as they can open the gates again, and then it stops. To give you an idea, this is a 750 liters per second pump station. It has a 30-inch suction pipe and a 24-inch discharge and a 3.2 meter by 8 meter wet well. And it's a little bit undersized for the right size based on standard accepted practices. Those practices are moving 7 millimeters of water per 24 hours of volume pumped. That means that if we get 7 meters of rain and all of it runs off to the outlet, we pump that off in 24 hours. Now, not all rain is converted 100% to runoff, but if we said that there was a 2-inch rain, a 50 millimeter storm, and 25 millimeters of it runoff, it would take 4 days of pumping with a standard pump in order to move that much water off the watershed. And so this Point Abino watershed is 752 hectares. It requires a pump roughly between 600 liters per second and 1,000 liters per second. And so it's just a bit under this pump. And the original historical size is a little bit, quite a bit smaller than that. It's about half that size. This is talking about, so we've talked about the baseline, and we're talking now about our modeling of how the watershed functions and what our goals for the watershed are. We're basically testing the watershed if it meets accepted standards. And what we want to get to is a storm that is 68.9 millimeters in 24 hours. And the type of storm we use is called the Soil Conservation Service type of storm. Some storms are different intensities. And so this is an accepted one for an agricultural watershed, is the SCS type storm. So if we get this much water, we'd like to see the drain function to pass this much water in 24 hours. We have had more storms bigger than that. We have had storms 63 millimeters in 1991 in 2 hours. And so that would cause flooding, even if we have a design that meets what we want. 79, we had a 100-year storm, 105 millimeters in a 12-hour period. So we have had bigger storms. This is what the watershed model looks like. We break it into these individual pieces, and we predict how much water will run off to a specific point. That's what these blue diamonds indicate. And then we figure out how much water moves from point to point all the way to the outlet. This is the kind of view that we get out of that. And you can see that a third of the upper watershed, this is Holloway Bay Road right here. A third of that has quite good positive grade, and there's excess capacity for the drains to pass. Once we get to Holloway Bay Road, we have a lot of challenges in the outlet, and we have some challenges in our survey results. So I find it hard to believe that there is this bump, but it's the data that we have this far that we have to try to clarify to understand how this drain is getting out here. But these points on average at 0.04 and 0.02 match the historical conditions. Besides the computer model, the hydrology part, we look at the survey and we look at the individual sections and we calculate how much hydraulically they can actually pass. So the model really does an idealized trapezoidal channel of dimensions that we provide it, but we analyze these individual sections to calculate what their actual capacity are at that specific point. And that's what this is showing here. In addition to that, we do analyze all the culverts, the same kind of thing, to see if they meet that 1 in 5 year objective. And this is one of those culverts, this particular one here. And we call it, it's in yellow because we call it marginal. And you can see this is the predicted upstream water side, which is higher than the roadway, which is not desirable. In order for this to pass, it should be down around here. However, this one is not a road culvert. So if it's a road culvert like this culvert on Holloway Bay Road, it has to meet the 1 in 5 year because it's a local road. This is an entrance culvert to someone's private property, and the standards can be a little bit less, a 1 in 2 year instead of a 1 in 5 year. And we don't like to see that because those culverts hold water back. And so you can get an idea of how that is because the culvert immediately upstream is a concrete box culvert, 1.2 meters by 2 meters. And this one is a corrugated circular steel pipe that's 0.9 meters in diameter. And so the equivalent area here is not a match. We've analyzed all the culverts, and these 4 are undersized. And so they are something that we could fix as part of our report. Specific improvements that I'm going to go through what we think are things that we have to address in our report. And number 1 is the East Branch. Do we keep the East Branch? Do we abandon the East Branch? As it is right now, the proposed boundary goes through the upper part of the East Branch. And so we really can't have water that crosses a boundary. So we'd have to resolve something in that at the very least. Number 2 up here, there's not a lot to do here except really show a revised grade line in metric from, improve the one from 1983, but it's kind of like housekeeping. There's no dramatic improvement here, but we produce new plans by which Alana can seek to maintain this drain every 5 years in good condition using our updated plans. And that's the main goal for both 2 and 3, is that these have available grade to work with. And by restating the design targets, they can then monitor their excavation to ensure that it's hitting the design grade every time. They become a maintenance activity. And now we're at 1, 2, 3, 4. 4, the Point Abino Road culvert replacement. So we can replace it and increase the capacity. Instead of 2 individual cells, we could have 1 cell. So there would be a greater room to pass water. There are a lot of challenges in doing that, but it is an opportunity for us to look at ways to improve how the flow gets out, but there's no magic solution in that one. Now, number 5, this north-south reach, maybe there's an opportunity to increase flood capacities in through here. However, the existing area, it's not like anybody's trying to farm this. And so the land is already getting flooded as it is. And so I'm not sure that we can actually naturalize this section because it's already quite natural. And number 6 is increase the outlet capacity through pumping. And I have some more discussions about number 6 and number 4. This is the Point Abino Road culvert replacement. The total length is 86 meters, I believe, and it's really broken into 3 pieces. There's an outlet piece of 9 meters, the Point Abino Road crossing piece of 14.8 meters, and then this portion that's adjacent to Abino Hills Road of 62.9 meters. That's really just providing private land access. The inspection quoted a $2 million capital replacement cost. Now that's not a detailed cost assessment. It's a very rough, typical cost assessment. And if we split that into the pieces that are the town of Fort Erie's, which is for Point Abino Road's crossing, that's 23.8 meters. It works out that they would be responsible for replacing the outlet to the tune of $550,000. The remaining portion of this is $1.45 million, and that would be the responsibility of someone else. It's 2 private accesses, which even, so that if we rebuilt private accesses using culverts, roughly $200,000 for a total of $400,000. And so replacing this the way it used to be is not likely to happen unless there's some way to do this without the cost that we're expecting it would take to put it back the way it used to be. So a little bit about the pumping station. This is a design that was prepared in '96. Showing kind of the rough layout, and it's consistent with the same design that was done in '93. It has an electrical motor. It has a building that sits on the top. It has a 1.2 meter pipe that draws water from the existing concrete culvert. It then discharges it through a 300 millimeter pipe to the lake with backflow prevention flaps on the end. So some of the things there is drain level monitoring. That's what would happen here. There has to be some monitoring to turn it on and off. It's an electrical motor, so there's a challenge with site backup power. If the power in the area goes out, this no longer runs. Power in the area often goes out because of storms, which is the very time when you would like this to run. If you're going to have backup power, it's typically going to be a diesel powered genset. If we were lucky, we could get a gas powered genset generator that would provide the electricity to run the motor even when the power goes out. We then need electrical equipment in order to switch it if we lose power. And then there's issues about where this would be situated. And then the second one is, since this was prepared, there have been improvements in submersible pump types, which would allow us to run this without the house. Really, everything would be below grade and it would be a submersible pump. That's kind of a trade-off because the submersible pumps are a little bit more expensive, but we lose the need to maintain or build a building above. So this is just a little bit about the pumping station in recognition of the options that we're looking at with the culvert replacement. The original pump station is located on private property in 83 on the Buffalo Yacht Club lands. And using our modern geographic information system overlaying with property lines, we can actually see that the pump station has the ability to be fit on the existing road allowance, but not on the road. And it would have a draw pipe that goes over to here, which in the future could be an open channel of some variety, which when we're drawing from one of the cells, not the whole drain, but one of the cells, there's a risk that we starve the pump. So all of these things have to be designed so that they meet the same rate of flow capacity. Otherwise, the pump will end up being starved. Water won't be able to fall into here by gravity fast enough to be pumped out. And then the pump goes on and off more often than is desirable. So the pumping station, this is what we're expecting to do as a rough estimate. It's, let's just say $450,000. I don't know that that's what the cost is because we haven't done this yet, but for the sake of argument, let's say that a brand new pump station is $450,000. We have to have people pay that. And the way we propose to do that is a combination of standard Ontario Drainage Act assessment practices, which is a portion for benefit and a portion for liability from runoff. So the properties that are below 176.5 meters in elevation have a direct benefit from the existence of the pump. Now, in other places, not the Beaver Dam Drain that I showed, but the one to the west of it in Wignall, there were a collection of farmers and they paid 100% of the cost of the pump. And it's because they were willing to realize 100% of the direct benefit. It could be 30% is for the people who get the direct benefit. And then the remaining 70% is paid as a property liability for outlet runoff, meaning the entire watershed pays the remaining portion of the pumps. Now that the challenge in the Drainage Act is that for this to occur, it has to be done under a petition practice. And the majority of the owners, more than 50%, would have to sign saying they're willing to pay this cost. And of those majority of owners, they have to represent more than 60% of the land area that's being affected by this. So what we're proposing to do is to prepare a separate report called a preliminary design report, where we provide an actual estimate of a proposed design for a pump station. we assess everyone what their proposed cost would be. And we have rough drawings that show where it would be and what it would look like. And then if more than 50% of the owners affected sign up for that, then it goes to final design and proposed for construction through the Drainage Act. But if it fails to meet this test of more than 50% of the owners, it only goes as far as the preliminary design. So we're near the finish line, if everyone's still with me. The next steps in this are the design details and beginning the review with agencies for their comment and approval. So one of the things noted in the original pump designs is that no environmental improvements were considered. And in fact, they can represent a significant cost. We start the process by reviewing with agencies what their requirements for approval would be, and we recognize what effort it would take to actually achieve those. And we do this by putting preliminary designs. We don't put a blank page down. We put a preliminary design down and say, here's what we're proposing. And then they tell us what studies they would have to show no negative environmental impacts. This draft final report, and if there's any petition for request to resolve, we're hoping to table in the fall. Following that, everyone gets to read that, and we have a public information center number 2, where we review all that information. Everyone gets to tell me whether they like it or don't like it. We can then make changes to the report, but that final report, recognizing everybody's input, goes to council for consideration. After council's consideration, there's a 40-day period for appeals. If appeals are recorded or received, then there's a whole process under the Drainage Act for a tribunal and a hearing and all of that. If no appeals are received, the bylaw is passed or accepted, and then we can proceed to tendering and construction. So there's quite, if anyone's looking for us to be out next Tuesday doing some work to implement these things, that's not going to happen. This is a longer process in order to ensure we're serving the most people in the watershed. And that's the last slide. My name again is Paul Marsh. My email contact is there, but I would ask you, if you have any comments, to direct them to Alana for her to manage the responses for them. And I would like to recognize Dave, this being his last meeting that I'm going to have with him. And I've really enjoyed working with him over the past 5 years, and wish him all the best. Now, I'm really hoping that Alana has joined back into the meeting, but I'm going to stop my meeting share.
I am here, yes, Paul. Sorry about that. My computer died earlier. So I believe everything's still recorded the way it was supposed to, because when I came back in, it said it was still recording. So if you have any questions, there is a raise your hand function. I believe that is under reactions. So we can take one question at a time, and hopefully Paul will be able to answer those questions for us.
Alana, can you hear me?
Yes?
I'm on the telephone, so I cannot raise my hand on the
Yes.
Zoom call. May I ask a question, please, of Paul? And my name is Charles Kreiner.
Yes, and your last name, sorry?
Kreiner, K-R-E-I-N-E-R.
And your address?
683 Point Abino Road South.
Perfect. Go ahead with your question.
Paul, thank you very much for the thorough presentation. Very informative, and I thank you for the time. My question is, or I have actually a couple of questions. I think it goes back to the C.J. Clark report of 1983, and it talked about the Point Abino drain and Point Abino itself. And when you are on Michener Road and you start going south on Point Abino Road, there is a road called Oriole Lane to the right. And according to that report of Clark's, The road then slopes down from Oriole Lane down to the point, down to the water. And that report stated that decline in the road at Oriole Lane was the old shoreline of Lake Erie. So over thousands and thousands of years, sand is accumulated, creating the sand dunes on the west shore, creating the dune structure, so to speak, along Point Abino and Bay Beach. And then we get big dune structures again when we get back to Crystal Beach. And in that report, they talked about, and you were referring to it in your commentary about a bathtub, that this whole area is just sand. And so as the water level rises in the lake, it permeates through this sand into the area that causes all this flooding. The flooding is not necessarily reflective of the amount of water that's coming from rain or being brought down from Port Colborne, that it's being driven by the rise in the lake level. That if the lake level stays high, no matter how much pumping you do, you're never going to really succeed in drying the area out based upon the recent problems that all the property owners have experienced. So that's one comment that I wanted to make. And then the second was with your picture of the outlet by the Buffalo Yacht Club, showing that outlet was in fact working. The color of the water is not blue like the lake water. And is there a pollution factor? Because one of the things that was brought up before with the prior drain studies was the runoff from the fields in Port Colborne and in Ridgeway, the farmers' fields with fertilizers and phosphates, plus with high water levels compromising septic systems. So some of the effluent that's coming out would not be just lake level that has come into the marsh, so to speak, but a combination of phosphates, septic tank runoff, as well as the lake level. So there's my commentary. So I guess I'd like you to comment first of all about the issue of the water level moving back and forth through the permeability of the sand, and then also with the issue with respect to pollution by the Buffalo Yacht Club.
Thanks very much for that, Mr. Kreiner, and I'm sorry I lost your first name in that. But
Charles.
Charles, you're right on with your comments there, is that if we wanted to pump out water from the lake leaking through the sand dunes, that's really a tough place to be. You know, that's a lot of pumping to try to keep the lake out. The only potential saving grace in that is that it doesn't leak in through the sand dunes very fast. So there's an issue between how fast rainwater comes off the upper watershed and how fast it leaks through that western boundary. But pumping to manage any of that water is a significant cost and undertaking. But if we were to say that we just wanted to pump the runoff, that's a possibility. It would also work then to lower the level when the lake is moving in, but man, that's a lot of pumping to have to do. So your comments are certainly physically or functionally how I think it works. And it's just the nature of the Point Abino drain that it has this impact. And then the second one about the Point Abino road, and the fact that it switches in through there. The only comment I have there is that boundary that we're recognizing with the Point Abino Road pump station study kind of lets me off the hook there, because that area you're talking about becomes their problem, not the drain problem. And until they revise the boundary, everything west of that boundary is the problem I'm looking to solve. And everything east of that boundary is the problem they have to solve. And I believe the area you're talking about is the area that they would have to solve as a problem.
But the issue with respect to pollution, who is
pollution, yeah,
responsible
pollution,
for that?
So if you look at any overhead photo along Lake Erie, Lake Ontario, any of the Great Lakes, you can pretty much spot where city outlets are and where creek outlets are. And there's definitely a pollution load from all of that wherever we've converted from forests to farms and subdivisions, which is pretty much everywhere. Now, whether you go so far as to call it pollution, that you can't judge that just from color, just because if you had a completely natural contribution that's running off from the land, it's going to be a different color than the lake. So the pollutant load is something that has to be analyzed, and that's out of scope for what we would look at with this study.
Thank you.
I see Andrew has a question.
Good morning. I just would like to say thank you for doing this meeting today. My name is Andrew Grine, and my address is 4906 Bay Woods Road, right off of Abinal Road. Two things. The first one is because of the ash borer and the ash trees that have died, they're not obviously sucking up the water that they used to around my property. But behind my property is wetland area, and with the trees that have fallen or fell, they are now blocking the path that the water has to go to get to the drain. And I would like to have somebody come in and move those trees because the water is sitting on my property with nowhere to go. But the second thing is I would also like to see access points to the drain. I'd like to see one at the end of Bay Woods Road, and I would like to see one at the end of Wildwood Road. With the trees, most of the trees are dead, being that most are ash trees. I think that this would be not that difficult to put in access points in those two places. And that's just what I wanted to let you guys know. So thank you very much.
Thank you. Mr. Marsh and I will work on that with Fort Erie's newest drainage superintendent.
Thank you.
The next question I see here is from Richard and Beverly.
Hi, it's Rick Trojaner here. Thank you very, very much for the good presentation, Paul. A couple of questions. One kind of building on what Andrew just mentioned there. Oh, by the way, I'm at 551 Point Abino Road South. The one building on what Andrew was just mentioning is the whole issue of maintenance of the drain. You haven't addressed that today in the presentation. Is there something coming out in your final report in terms of recommendation of frequency of maintenance? I think we've had a lot of issues with beaver dams and as Andrew mentioned, the fallen trees, other debris building up along the drain that causes backups. And I'm not 100% sure who's responsible for maintaining the drain, and whether you also in your report, whether you've considered improving the access. I know it's difficult for the town to get in and do the work in there, but I think there needs to be some additional work done around providing better access for maintenance. The other point I wanted to ask is about, I know in your presentation you mentioned briefly that there was consideration of an additional outlet either at Pleasant Beach or Holloway Bay. That seems to me to be another way of perhaps reducing the amount of flow necessary down the lower length of the drain. Is that still being considered? And if not, why wouldn't that be a good way of reducing the flooding at the south end of the drain?
Thanks for that question. I'm gonna take that. I'll try and stay with it all the way to the end, but please remind me if I leave anything out. So number one is on maintenance, is that the last report for assessing the cost for maintenance was completed in 1983. And so both Alana and Dave want this new report So there's an updated assessment schedule to assign costs to everyone for maintenance. Both drainage superintendents are wanting to do maintenance, and the challenge is having this updated report so that the costs are shared out fairly and everyone's had the chance to see it. I know on Alana's side, she's aiming for a 1 in 5 year cycle for revisiting maintenance on a needs basis. So every 5 years, the plan is to go in and do maintenance unless it's identified that it's not needed at that time. The gentleman before you that made the comments about the emerald ash borer and the ash trees dying is a maintenance problem, because they are dropping branches or dropping the whole tree in and causing obstructions in drains throughout southern Ontario. And then if I can get to the next part, so I've talked about maintenance, and the next part was, remind me again, please.
So on the maintenance side, I also wondered whether your report from a design perspective would consider access to the drain for maintenance, because I think it's very difficult the way it is now for the town employees to get in to be able to do that maintenance.
Yeah, you're exactly right. As part of our report in our plans, we actually show access points on the plans, and we actually in the report designate how physically machinery gets in order to access the drain. And as part of that identification, people are paid a benefit for allowing access across their lands in order to get to for maintenance. So as part of the updated report, we recognize these, they're not quite easements under the legal term of what an easement is, but under the Drainage Act, they function like easements. And then you had a third point.
Well, the other point was whether you're still considering a secondary outlet at Pleasant Beach or Holloway Bay.
That's something that's going to have to be under discussion between Alana and the people in, like the client in town of Fort Erie, Dave's replacement, is whether we continue that as a study or not. I know we've looked at it in some other places, and just looking at the contour lines, for it to be a gravity flow into the lake from either of those places, there's some real challenges to getting there, which is why I think originally they looked at doing a pump station rather than trying to do a gravity flow. But it is something that would be worth having a discussion about and looking at. And I'll make a note to bring it up with both Alana and Dave's replacement.
Great, thank you very much, Paul.
Thank you for your question. The next question we have is from Mr. Wells.
Thank you, Alana. Thanks, Paul, for the great presentation. A couple of little questions here. The most westerly portion of the drain seems to end in the Shirkshin Shore Resort. And there has been a lot of development within that portion of the resort with the elevations of the property being raised quite significantly with the import of various types of soil and material. Has there been, does your report include any flow, additional flow from the resort itself?
So in the baseline report, we identify that we're making revisions from the old watershed boundary to a new proposed watershed boundary based on the 2012 plane orthographic survey of GIS information. So I would hesitate to say that we're showing recent developments in that, because the data that we have to work with is from 2012, but it's much newer and higher quality data than was available in 1983. So there are revisions in the boundary, but as to whether that's, I believe some parts are more and some parts are less, depending on what was shown. So I would encourage you to look at the baseline report mapping, where we're showing the details of where the boundary's been moved to. And then if you think there's still some things to address there, I'd be happy to hear about it. at this stage, we don't have a plan to actually survey to determine boundary.
And then a follow-up question with that then is that does the Shirks and Shore Resort have a permit to take water, and do they pump water from either the ponding or the property, the quarry, into the Abino drain?
So we did a review of permits to take water, and I don't recall seeing one on the ministry website saying that Shirkston Shores has a permit to take water. But that doesn't mean they're not taking water. That just means there's no permit recognizing that they take more than 50,000 liters per day. If they're under that threshold, they wouldn't have a permit needed to be granted. And so they may be using some water. I don't have any knowledge of that, but from our baseline review of available information, there isn't a water taking permit granted recognizing more than 50,000 liters per day.
Thanks, Paul.
The review of the design for Shirkston Shores, both the region and the city, are ensuring that it is the pre and post development flows are equal. So there shouldn't be an additional flow coming from Shirkston Shores, according to the design.
And is that, Alana, is that included in that would not be included in the December 16th report then? Is that correct?
No, that would be included in all of the development of Shirkston Shores.
Right, but that flow, that additional flow that would be coming from there, if any, that would not be in the Point Abino Drain report at this time?
No.
Okay, thank you.
I see our next question is from Janine, sorry.
Hi, it's Jenny.
Thank you.
Hi. Did you want me to go ahead?
Yes, please, with your address first.
700 Pleasant Beach Road.
Thank you.
Hi. I'm basically just wanted to ask about how this type of project, I mean, the status of it, obviously it's far away from being resolved or completed, but how the status of that affects building permits for new builds and severances and things like that in the area directly affected. We had inquired about a severance back in 2017, and we were told that until the watershed issue was resolved, there wouldn't be any more building in this particular area. And since then, there's been many new houses have popped up. So obviously, it doesn't seem to be too much of a restricted factor at this point. I would assume that until there's a very specific building plan in place, it wouldn't affect that. But I was just curious to see if there were any boundaries or limitations involving that, at this stage.
I'm
not sure I can answer that, Alana. Perhaps you'd like to take a crack at it.
Okay, back in 2017, the drainage superintendent that was here made a request to the planning department that severances and that weren't approved. And that was supposed to be for a 1-year turnaround in hopes that the report for the Point Abino drain would be complete. I think that was a bit ambitious myself. But I know that there are still severances that are allowed to happen. The more severances we do, there's less land that's available to just have water sitting on it versus somebody having water sitting in their front property
right.
or their house. So having the report completed and being able to accommodate the flows is certainly a benefit before we allow more severances. I'm not saying that we're not going to allow more severances. It would just be a benefit to have that completed.
Okay, and can I ask one more question?
Certainly.
Obviously somebody else had mentioned the ash borer, and we all know how disastrous that's been in this area. Is there a parallel conservation project that's going to be partnering with this? Is there anywhere we can look for information about the possibility of restoring some of the trees and things like that in the area that pairs well with this drainage issue? I'd like to read about what proactive plans there are for the city in these areas, as these are just disappearing by the year. So if there's somebody that, like I said, if there's a parallel project, I'd be interested in reading about, what the initiative is around these kind of road end towards the water issues, as far as regenerating some of the trees and things like that.
So there are several programs. I know one of them is run through the region. Another one, well, the region is working with the city, our Parks Department, to try and replant trees. Unfortunately, we didn't have much to do with the emerald ash borer. It just came and devastated that we had. As far as maintenance on the drain, if we are removing a live tree through our program, our intention is to replace a 2-for-1. So if we cut down a live tree, we want to plant off the maintenance corridor or back off the maintenance corridor so that we can continue to have trees, because yeah, we all do love trees, and it breaks my heart when we have to cut them down. I don't know if Paul, if you wanted to mention a little bit more on that.
No, you got my.
Yeah, I know. Like I said, I'm just curious as far. Sorry, I didn't mean to talk over you.
Go ahead,
it's tough
Jeannie.
on the Zoom. Oh no, that was helpful. Like I said, I want to make sure, obviously, that these these conservation projects are so essential to these water displacement issues. So I would love to hear a little bit more about again, yeah, the details of how that's involved in this, and whatever other projects kind of serve this area as far as the conservation and replanting.
I have your email address through your registration. If I do find out about anything specifically, I will certainly let you know.
Yeah, that's helpful. And I apologize. I didn't mean to speak over you there, Paul.
No, it's okay.
Our next question I see here is from Scott. If you'd like to start with your address.
Yes, this is Scott Soibert, and my address is 857 Point Abinal Road South.
Okay, go ahead.
Well, thank you so much for having a public meeting on the subject, which is interesting to all of us. Paul, that was a great presentation. I've been to a couple public meetings about improvements on the drain, and you've explained it very well. It certainly would be helpful to be able to come up in person and look at those diagrams and drawings that you presented. If you had them up on an easel, it would probably explain the situation a little better. But as far as a virtual presentation, it was really nice to have it. And it's also nice to see some of my summertime neighbors here. You made a comment partway through the presentation that during the 1996 public meeting proposal, that many of the residents opposed the cost of the project at that time, which is true. There was some opposition to the cost. There's another factor that comes into this, in that a lot of the area that's served by the drain is an area of natural and scientific interest in Ontario. It's a fairly big deal locally, and several of us who live in the area enjoy a conservation tax, a real estate tax abatement, if we promise to keep our area of our property that's served by the ditch and that's within the area of natural and scientific interest, leave it natural. And I believe that some of the opposition to the 1996 plan was not only in opposition to the cost, but to some potential detriment to the environment that running a pump might cause. And I guess my comment today is that I think that opposition to pumping out a natural swamp is still alive today. And that differs from improving the drain. For instance, you mentioned undersized culverts, the condition of the outlet at the Buffalo Yacht Club. Those are conditions that I think even the most avid environmentalist would say, the drain has been here for almost 100 years. We don't object to the fact that there's a drain. there is some opposition to what could be the consequences of artificially draining the area with a pump. And I think that opposition is alive and well today. Maybe in the fall, when you have the second meeting, we'll have it turn out and hear what people have to say on that subject.
Well, I'd like to thank you, Scott, for mentioning the tax abatement, because that's something I didn't record or recognize in my baseline report. And so it's good to hear that that is actually a thing, which I didn't know about at the time. And one of the challenges of the drainage engineer is that my personal views about pumping or not pumping, I'm to remain as an agnostic on whether that's a good or a bad idea. And it's really one of the challenges of the Drainage Act, is that it's intended to serve the collective good, the majority of people's interests. And with the rise of environmental protectionism, there are opposite views how that is supposed to happen. And so we do have these challenges where, and it's in the 1983 report, is that this watershed is not really very agricultural. And so the Drainage Act is originally intended to serve agricultural properties. What we've been trying to do in the more recent times is to recognize the Drainage Act as an aid in water management, and not just for agricultural purposes, but to serve everyone's interest, protect the environment, reduce pollutant loads where we can, and to achieve an overall benefit, because there is a way to do cost recovery on those activities. But it is a requirement for the drainage engineer to seek the biggest consensus of watershed owners through the report. We'll see how I do.
Yeah, it's interesting that the criteria for funding the project requires both a majority of property owner individuals and a land area. And there are several land area parcels that I believe are still farmed. And, you know, there's a question involved as to whether those farmers feel that placing a pump way downstream would actually benefit their operation. I guess that's for us to see.
Yes.
Thanks so much.
Thanks for the question.
Next question we have is from Mr. Rusk.
Yeah, thank you, Elena, and thank you, Paul. That was really an excellent presentation. Is the recording of that presentation going to be posted somewhere?
Yes, the recording will be posted. I'm hoping to post the recording and a copy of the presentation both on the website. They'll be under Living Here, Municipal Drains. And then I believe it will be under supporting documents or history. I don't recall off the top of my head, and I'm afraid to. I'll put it in the chat link, but it definitely will be on the website. And I'm hoping,
yeah, that'd be helpful, because
there
were a lot of people that probably would like to hear that, but weren't available today to listen in. I got a couple of questions. Paul, you had mentioned, and by the way, my address is 571 Point Abinal Road, South.
Thank you.
I'm, you know, part of the group that's, you know, trying to develop some better recommendations for the flooding that occurred in our area, you know, in the along Point Abinal Road over the last couple of years. And one of the things that I was interested in hearing from Paul was that there was a significant slope when you're going down to Holloway Bay, and then it kind of becomes less significant. The slope declines as you get closer to the outlet by the Canoe Club and along Point Abinal Road. And given that you have the greater gravity flow along Holloway Bay, wouldn't it make sense to have a separate outlet there where you have you know, a good flow going into the lake?
It's an option. It's You know, one of the challenges I've seen and experienced in working with Port Colborne and Fort Erie over the last couple of years is typically when we see these opportunities that look like a good idea, there's often a reason why they didn't do it in the first place. And it takes us a little while to get to understanding why they didn't do it in the first place, because it might not always be completely obvious as to why they didn't do it in the first place.
Do you have any idea historically why it was not done?
No, but I noticed that in the one report they did rock removal, and so it could be that there's a significant amount of rock to cross in order to get to that outlet, and that is an interesting challenge when you look at their historical efforts to remove rock. Whereas with the machinery that we have today, it's a little easier for us to consider rock removal as a methodology for achieving drainage. When we do that, though, it really has pretty significant impacts on how the drain functions, just because we're kind of breaching what was left behind in the last glacier. And so, yeah, so that's just
well, it seems like it'd be worth looking into anyway. The other question I had was on the flap gate controls. I'm confused as to whether there are any, if those flaps actually move or if they're fixed in a closed position. I'm not clear as to what was done on those flap gates when they did the repairs.
So and actually I could go back to the picture, but for just the gates are on a frame and they hinge about a rod that allows them to open and close automatically. It's called a passive control. So the force of the water pushes them open and then the water swings around them. That's why the weight of the gate has a function on the rate of water flow. Let's say the gate, instead of being made of steel, was made out of plastic. Then the water would have an easier time pushing it open. And then when the lake came up and pushed it closed again, as long as it makes an effective seal, it will keep water from running backwards. And so that's a potential issue in the success of one of those flap gates. If a dead ash branch gets trapped at the lip, then it doesn't successfully close, and then water will move backwards in it. And so it's those two parts. And the passive part allows it to swing open to allow water out. And then when the lake does come up, it automatically closes based on the pressure of the higher lake.
So right now it's functioning properly as far as you can tell.
Right now it's functioning properly since they rehung it onto the concrete face.
Okay, and then in those, you said they were poor to fair, medium to poor condition of the basins behind that. How does that affect the discharge from the drain?
It doesn't actually affect the capacity of the drain. These are structural defects that we're observing. And so it goes and speaks to the reliability of the structure to remain in place. And it represents a risk to the town of Fort Erie, which is why the town of Fort Erie would take the lead in assessing this risk and choosing a reconstruction decision. In that, it's kind of difficult to predict to the minute or the day or even year that a concrete structure may last, but you don't really want to risk it where there's a road passing over. And when these voids happen behind it, soil is allowed to fall out and into the drain, which then washes out to Lake Erie. And then you can have a sinkhole show up, which,
okay.
That's what we want to avoid. And it's why they recommend that the town begin monitoring for that to occur, because there's the risk there. But they're just identifying a risk. And so what the town will do is to plan for that risk, develop new designs to replace it, and then do it in a planned, staged manner in cooperation with the drain report.
And just following up on that one comment you just made, as far as the town's involvement, you just mentioned they have a monitoring role on the gates. Do they also have, and this is town of Fort Erie now, I assume that they have a maintenance function that for the drain within the town of Fort Erie limits, which would be along Point Abino Road or behind Point Abino Road to the west. But there's also a pump, we call it the Porter Tennis Court pump, which has been a problem. And I'm assuming that's considered to be east of the drain, so it'd be a Fort Erie issue and not a Port Colborne issue.
That's correct. Yes, maintenance is done by each responsible municipality within the parameters identified in the report. And yes, that is the pump station that I referred to in my presentation as the Point Abino Road pumping station.
Okay.
And
that would be
is what,
and that's the town of Fort Erie's jurisdiction, not Port Colborne.
correct. And it's not part of my scope of work within this report. That's the boundary that I was talking about, where if they're handling it in the pump station, then those lands will deal with the pump station. And lands to the west of the pump station boundary will be in my report.
Okay, thank you.
You're welcome.
Before we jump forward to our next question, there was a chat that was going on. And there was a question regarding the Holloway Bay outlet that used to be there many years ago. What I'm going to do is share my screen just to give you an idea of where that was. And I believe that's what I'm going to do right there. So Holloway Bay Road South. Oh, sorry, I'm not sharing yet. I forgot to share. Am I sharing the right thing?
Yes.
Okay. You're seeing my.
Yeah, it's on the screen. Yes.
Okay. I have a bunch of stuff in front of it, so excuse me a moment. There we go. So the Holloway Bay Road South comes here, and that outlet was actually right in here in this blue area. The pipes are still there, a portion of them. What had happened was when that pipe was installed, because that is the windy side, most prevailing winds come from the southeast or southwest, my apologies. There's nothing that can protect this outlet here. And the beating that it took within the first year made it non-functional, which was unfortunate that so many dollars were spent, and within 6 months' time, that outlet was basically annihilated. We understand that through the one map that Mr. Marsh was showing, that yes, the lake level rises down in Fort Erie significantly, but it doesn't have the wind effect on the backside of the dune like it does over here. So having an outlet at Pleasant Beach or at Holloway Bay Road, even Matthews Road, if that were to extend all the way down, the beating that it takes from the wind direction is just, we can't protect that. I shouldn't say we can't. I'm sure something could be done, but the cost would just be prohibitive. So having the backside where the outlet is protected from the wind is the major benefit. And I'm going to stop sharing. And what I'll do is bring that over to Mr. DeFabio, if you have a question.
Yes. Good morning. So I had a suggestion. So the province of Ontario has implemented secondary dwelling units. And my property is located at 557 Point Abino South. It's about a 3-acre parcel. And we're getting a lot of flooding this year. And again, concurring with everybody else, even we went to cut some trees for firewood that were down, and they're just basically useless or waterlogged and can't even use them for the fireplace. And what a lot of third world countries have done in the past is, even in areas where you have had services, which we have water and sewer there, you install septic or cisterns. And this would be a very viable option to do two things: to do infilling from the perspective of secondary dwelling units, which is a mandate from the province, and force these secondary dwelling units to have cisterns. And I believe that part of the bylaw stipulates that if you're in a residential zone, you can't have a cistern, but you would have water going into the property, which would be a secondary means to accumulate water. And what that would do, it would take away from, first of all, a lot of the surface water that's there. And imagine if you had 100 houses there that did 100 cisterns, it would help out a lot. Unfortunately, the zoning there doesn't permit secondary dwelling units, but it permits it on a 30 by 50 lot, but it doesn't permit it on a 3-acre lot, which I think it's ridiculous. I think there's a lot of viable options there too, even with existing homes. There was a program that would allow you also to add a cistern in order to take some of the surface water away. And that was my thoughts. I think that'd be a simple solution to alleviate a lot of the water problems.
I'll briefly respond to the engineering part of that, but the planning part of the secondary units, I'll avoid. And part of what we've looked at in trying to do with our assessments is to recognize where properties are engaged in physical practices that reduce the rate of runoff and, you know, in engineering terms, prevent hard surfaces from contributing a lot of water quickly, or if they have those hard surfaces, that they seek ways like a cistern to detain the water and hold it back over time. And for those properties that do that, that we recognize a reduction in their assessment because they're achieving that benefit. Now there's a challenge in balancing that effort against what they're doing. And the challenge would be the cost of a cistern, which is a relatively fixed volume to be held back, but not zero. So it is a positive contribution relative to what benefit it's achieving on the overall. And so if we look at a 3-acre lot and we talk about one single cistern, relative to the size of the 3-acre lot, the one cistern's not a huge impact, but it is a benefit. And so we want to encourage these, what we call low impact development practices, where they seek active ways to reduce the runoff. That's a positive thing. And we want to incentivize that. The actual things are something we have to work with the 2 drainage superintendents and the 2 town councils to recognize. And we don't want somebody that gets the reduction and then immediately paves over the feature the following year. And then their maintenance records it forever, basically, but they remove the feature. So we want to make sure that the features stay in place and keep delivering that benefit of holding water back. But so your idea is a valid one, but as to whether, and it's not just that, there's a whole range of opportunities that they can have and seek to achieve.
Even when you look at our property, we already have a garage in the back of it that's probably, I would say, at least 1,000 square feet or a covered area. So we already have existing structures that are already there in place that are really deemed useless. They were built in the 1930s, 1940s, 1950s, that should be demolished and built new. And now I know that it appears to be an insignificant amount, but a lot of the flooding doesn't occur when you get rainfalls that are large. A lot of the flooding occurs when you get rainfalls that are small. And if you're able to absorb that water and utilize it for the following months or following weeks, when you do get harder rainfalls, it puts less of a strain on the system. And I think it's a very simple solution. And again, I know that you can't, deal with the planning component, but it is kind of ludicrous that you can do right now in the province of Ontario in an R1 zone or an R2 zone, an accessory dwelling unit, and possibly 2 now with the new mandates on a 30 by 50 or 30 by 80 lot. But in areas where we're having flooding issues that are 3 acres and 2 acres and 1 acre, you can't do anything. And it's
there is an issue on this watershed where there's not a designated flood zone, but the Conservation Authority is still regulating flooding within it. And so there's a general concern that the province doesn't want to see more residential units built in flood areas. And within the body of engineering that we're doing, we know that climate change is having an impact, but we're still seeking a way to understand numerically what that impact would be. But in the interim time, they're seeking more fudge to ensure that the flood zone may expand, that we don't encroach into it with new development that's putting more people at risk. So there is that place there where we want to leave room for the river or leave room for the drain, because with increasing climate change storms, there's going to need to be more room. We don't know the number yet on that. As an engineer, I don't know exactly how to represent that. There are some theories out there about how to do that. And so I'm going to just end it there saying, yes, you've raised an excellent point about doing the most we can on our properties to reduce runoff. And the planning part, I will leave to planners. Thanks very much for your comment.
Thank you. Thank you.
Okay, I don't see any more questions at this time. As Mr. Marsh said throughout his presentation, if you have any more questions, you can either forward them to myself or to the town of Fort Erie. Give somebody another two, they have a last minute question. But otherwise, I want to thank you for coming out to the meeting. And like I said, the meeting will be posted. It will, as well as the presentation. And in that same location where you found the upcoming meetings, if you scroll all the way down to the bottom of that page for upcoming meetings, there is a section where it says supporting documents. And that's where these two files will be stored, both the meeting and the presentation. So I see we're a little over our scheduled time. And thank you all very much for coming. And at this time, we'll end our meeting.
Thank you for your time, everyone.
I'd like to thank you both, Paul and Alana, Dave from Fort Erie.
Sorry, Dave, I forgot to let you speak there.
Oh, that's okay. I would just like to say thank you to yourself, Alana, and to Paul. Great presentation. I think it was very informative to everybody. Hopefully everything works out well on this drain.
Thanks for the good wishes, Dave.
Thank you, everyone, and enjoy the rest of your day.